Hello, this is the course of Introduction to Data Science. And in this section, I would like to teach you how to deal with categorical data. So we have one data set that we will learn, which is flights.csv. Okay? You can get the flights.csv later. So I will teach you on how to use the internet or the link for understanding the data. So first, now we will learn how the types of processing the categorical data. Okay. There are some techniques. Okay. We will learn about the replacing values, and then we will learn about how to input labels, and we will learn what is one hot encoding. Okay. And if it is about replacing values, it is to replace the categorical data with an understandable defined code. So for example, 1, 2, 3. If you have male, female, you can change to 1 and 2. Encoding a label, it is almost the same. You can encode the labels into the numerical code, but you can see with some examples later. One hot encoding is one of the famous way to do the encoding. And there are two other things that I will also explain, which is the binary encoding, okay, and the miscellaneous features. So we want to make some ranges about the values. So first, you need to import the libraries. Okay, I hope when you do the exam, you already prepare with those kind of libraries. And yeah, we want to check this flight. Okay, so you can, if you want to go to this link, actually you can see, this is the data in the form of CSV or comma separate values, and there are so many data of this one. So you can just go to this link. I do not want to consume a lot of space in my computer, so you can just use this link. And I use the read CSV, and you can have this data. Okay, and this is in the data frame in our computer, so you can see those columns. Okay. So the columns, I think I put, okay, I put this column name. Okay. So when you have your exam, I guess you will have the same idea like this one. And also when you do your assignment, I also give you the column name, and I also give you the description. Okay. But if it is not that detailed, you can figure out by yourself, okay, by looking at the data. For example, this is the year of the flight, the month of the flight, day of the flight, okay, and then we have the departure time, departure delay, whether the departure is delay or not, arrival time, and then arrival delay, whether the arrival is delay or not. We have the carrier name, the airline name. We have tail number. Oh, the detailed tail aircraft number. So every aircraft will have their own number. Flight number. Yeah, we have the flight number. As you know, if you travel by airplane, there will be a flight number. We have origin and destination. So where is the origin? Where is the destination? The air time, the travel time from origin to destination. Okay. The distance, so it is the distance from the origin to destination. And then hour, the travel distance in hour, and minute, the travel distance in minute. Okay, so you can take a look on this data, and then let's see if I want to know more about the code. Okay, this is a little bit tricky, because maybe you are not familiar with this airline code, but I put this one. UA means United Airlines, AA means American Airlines, US means US Airways, and so on. So we have this data, and we can do the analysis from now. So the next step is to gather some information about different column in your data frame. So you can do by .info, which basically give you the information about the number of rows, columns, column data types, and the memory usage, for example. Okay, so it will consume 19 megabytes. This data contains of 162,000 data. Okay, and this is the data. This is the column, and you can see the data type. It is integer, float, object. Okay. Okay, there are 16 columns for this one. So as you can see, columns like year, month, day are read as integers. Departure time, departure delay are read as floats. The column with object D types are possible categorical features in the dataset. Okay. So this one, object, 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 and object. Okay, so those objects are the categorical data, and we are going to focus on the categorical features. The reason why you would say that this categorical features are possible is not because you should not completely rely on the .info. The .info it show you the real data type of the value of the feature, but because some of the missing value is because if we have the missing value in that particular column, then if the data is continuous, it will be an object when we have the missing values. So you already know how this works. Okay. So first you can do the box plot. Okay, yeah, you can do anything for your analysis. Let's say I want to know the box plot from two origins. So here, actually, the data is only from the Seattle to Portland. Okay, yeah, I use a lot of data from Seattle. Okay, so Fremont Bridge, yeah, it's the data from Seattle. And anyway, I want to know the departure time column with respect to the two origin. So I can use the flights box plot. So this box plot, yeah, I would like to have the size figure, and then yeah, the rotation is just about the rotation of this text. Yeah. So the departure time. Okay. So the departure time is somehow in between this is the time. Okay, maybe I guess because the time is plotted as 0 0 0 0 and then 0 1 0 0 and so on. So maybe this is the data about 11. Okay, so in the median, so the data the departure time is about 11 o'clock something, and this data is the departure time is about 11:25, or yeah, I don't know, something in that numbers. Okay, so as you will be only dealing with the categorical features, so yeah, we can just filter. Okay, we will filter only the categorical data, and using the copy. Okay, so there's method copy. It is used here so that any changes made in the new data frame don't get reflected on the original file. Okay, so if I want to use this one, so I want to choose only the categorical data. Okay, so the categorical data here, it means the object. Okay, I would like to use the data frame from flights and data type, which is object. I would like to copy it into this variable. Okay, and if you want to see the first 5 data, then you will see that here we have the carrier, AS and US, UA. So I already show you the airline name. Okay, And then the tail number is the aircraft number. Okay? And this is the origin. The origin, there are two, PDX and SEA. It means the Portland and Seattle. And the destination, there are many. Okay? I couldn't mention all the things. Okay? So these four are the data that we are going to analyze more about the categorical data. So one of the most common data preprocessing step is to check the null values. Okay. Yeah, you already learned how to check the null values. We can use the is null, okay, or we can use other way to check the null values. We can use this one, okay, is null, okay, and then I want to check the values. So if you want to check only the for every column, then you can check until values, and then I would like to do the summation. So I want to know there how many missing values are there in the data set. So we have 248 data which is missing. So if I have this one and I would like to check this on the column, yeah, so I can just choose not the value, but I will just choose the sum. Okay, there are many tail number. This is missing. Okay, then how can I do this data preprocessing? We can use a way. We can, yeah, in this example, I would like to choose a chaining, yeah, method value counts. So this will return the frequency of distribution of each category in the feature, and then selecting the top category, which is the mode. Okay, do you know mode? Mode means the highest frequency in that data. Okay? So if we want to choose the highest frequency, then we can choose the mode. Okay? So here, actually, we can use the highest count. Okay, we want to get the tail number. We want to get from the column tail number, and then we can just do the value counts. Okay, and then we will choose the index 0. Okay, maybe if I do something like this one. Can I do something with this? Okay, so if I see this one, okay, so if I want to see the based on the tail number, okay, and then if I do the value counts, so this tail number N223AG is the top. So it means there are many flights using this aircraft. Okay. There are many flights using this aircraft. This is the aircraft tail number. So because this is the highest one, okay, so this is the highest, or the highest frequency, or we can say this is the mode. Okay, because this is the highest one, so I would like to use this one. That's why I use the index 0. So I use the first data, and after I use the first data, here is N223AG. So I put it into the missing values. So every missing values in the category, in this category, okay, I will choose the mode. Okay, I will choose the mode to fill or replace the missing values. Okay, so after I know that the mode is this one, and then I will use it for replacing the missing value, and we will get a new data with this variable. Then let's see. Let's check the number of null values after we impute. Okay, then after I do this one, okay, the missing value now becomes 0. Then there is no missing value. We can do the EDA. Okay, so that's the step. When you have your data, you can handle the missing value. After you handle the missing value, then you can use EDA to do the basic analysis about the frequency and etc. So we can do with the value counts, okay, at the earlier stage. Okay, for example, I want to know how many carrier. Okay, the carrier means the airline names. Okay, so if I do this one, okay, there are many airline AS. Maybe this is the American Airlines, okay, and so on. Okay. And if you want to know the count of distinct categories within the feature, you can change the previous count with count. So if I want to know how many aircraft or how many airlines here, I have 11 airlines. So I just get the carrier and then I count it and then I just do the count to know the distinct values. So the visual exploration is the most effective way to extract information between variables. So we can also do with the bar plot to check the frequency of the distribution of the categorical features. We can use the seaborne package, okay, and we can see the frequency distribution of the carrier column. Or you can play with different arguments to change the look of the plot. Yeah. So I think, oh, sorry, maybe I missed this one. So you can take a look on the other kind of tutorial, but I give you one example for this one. Okay. We use the seaborne, we use the matplotlib here, and then I would like to just use the carrier count. So I want to calculate how many carrier, okay, and then after I put it into this variable, yeah, I can just set the this is the style, okay, and then I want to use the bar plot. What is the bar plot here? The bar plot here, I want to use the index. Okay. I want to use this index for this bar plot. Okay. And yeah, we can check this alpha is also only about the transparency. And yeah, we have the bar plot is if we plot the index and the values. So index means each of the carrier. We have AS, WN, OO, and the values means the number of the data. Okay, so this is the data, and then we want to plot. The title is the frequency distribution of carriers, and the Y label is this one, and the X label is this one. So you can see the result like this. Okay. So the highest one is AS and WN, OO, and so on. So we can use the bar plot to see the frequency distribution of categorical values. So if we have the categorical values and we have the numerical values, then we can use bar plot. Similarly, you can also plot the pie chart at matplotlib library. Okay, yeah, you can use the like this one. Let's say I want to make the labels. Okay. So it is from the categorical data flight carrier, and I want to make it as a category. So I think I will explain this also more later. And I want to make it into list. Okay. So I want to calculate the counts. And then, yeah, I want to know the size. So after I have the size, so for every count in the variable category, I want to, because it is the label, okay, So I can make the plot. So the pi, so the size, it means the how many items. So here IS, AA, W, and so on. And we want to plot the labels here, and then this is only about the size of the font, because here you can see it's very small and we have 1.1 of the format. Shadow, we have a little bit shadow like this one here. And if the axis it is the equal size, and then we can show it. So when we are doing the when we are analyzing the categorical data, we can do the encode. Okay, so we will now learn different techniques to encode the categorical features into numeric. Okay. To keep it simple, you can apply these encodings only on the carrier columns. Okay. So you can extend to the other approach. You can extend to the other column. Okay. So here I will explain the replacing values, encoding labels, hot encoding, binary encoding. Oh, I think I will not explain the backward. This backward is a little bit advanced, so I will just focus on this one. So replace values. It is the very basic method. This is just replacing the categories with the desired numbers. So this can be achieved to be used for replace function. So if you understand the replace in pandas, you can also use that one. But the idea is that you have the liberty to choose whatever numbers you want to assign to the categories according to the use of your business. So for example, I want to map the number based on the carrier column. So if it is AA, I would like to plot it as 1. If it is AS, I would like to plot it as 2. If it is B6, I want to plot it as 3, and so on until 11. So I use a dictionary for this one. So we have key and value, key and value, key and value. And this one is the key, okay, and this is the value. Okay, so this is the replace map. And I will run this. After I have this one, that this mapping is a hard-coded dictionary. Okay, so we have 1 until 11. So you can achieve the same mapping with the help of dictionary comprehension as shown. And this is useful when the categories count is high and you don't want to type each of the mapping. And then you will store the category name in a list called labels and zip into a sequence of number and iterate over it. Okay. So this is a way. We have the carrier. Okay. And I want to put the carrier as the type of category. And then the category will be represented into a list. So we are making a label. Okay. Or maybe I can show you like this one. Let me just show you this and labels. So we want to make the carrier. I think because we already know the carrier AA as something, and I want to make it as a list. Okay, and after I make it as a list like this, then I want to check. Okay, I want to check whether the replace map. Okay, the replace. If you are doing the manually, if you are doing the manually like this one, you can have this one AA1, AS2. If you already know the data. But if you do not know the data, then you can do something like this one. So the replace map computational. Okay, so you have the carrier, which is the key, and then I have the K and V, which is the key and value, and I want to use the zip based on the labels. The labels is here. So every label, which is AA, AS, B6, will be in the list of range from 1 until the length of the label plus 1. So if the labels is AA, we will start from 1. And then next we will go to AS and the label will be 2. And then next we will go to P6 and the label will be 3 and so on. Okay. So this is the automatic way. Okay. So if you know, if you understand how to make this kind of looping, yeah, you can use this way. So throughout this tutorial, you will be making a copy of dataset, the copy method, and practice its encoding technique to ensure that the original data frame stay indexed and whatever changes you are doing happens only in the copy one. Okay. So I use this new variable replace, and it is a copy of the original file, and use replace function in the data frame for mapping the dictionary like this one. Okay, I have the replace variable and I want to replace it according to the replace map com. So the data in replace map com contains the key. What is the key? The key is, yes, carrier. Okay, because I know that the key is carrier, so I want to change the carrier. I want to change the carrier according to this replace map com. Before we already have the definition, like if it is AS, it is 1. If it is AA, it is 2, and so on. Okay, then yeah, the number represent the airline name according to the dictionary. Okay, so if I run this, then you will get this number, and yeah, as you can observe, you have encoded the categories with the map numbers in your data frame. So you already replace the values with numbers. And you can also check the data type in the newly encoded columns, and it is now converted to integer. So if you check this one, the replace, when you replace the column carrier, now the data type is integer. So in Python, it is a good practice to typecast categorical features to a category data type because they make the operations on such column faster than the object data type. So you can do this typecasting by using S type. So for example, this one, okay. I have objects. Okay, I have objects. When you do with object, yeah, it's categorical data, but you can replace with the category because it is more efficient. Okay, if your data is a lot, changing to category is recommended. Okay? So I have the category flight LC, so I just copy, and then I change the carrier. Okay? So the carrier, the first data type is object, and I change to category. The same with the origin. The first data type is object, and then I change to category. Okay. So after I change this one, then I will check. So you can validate the faster operation of the category data type by timing the execution time of the same operation done on the data frame with columns as category data type and object type using the time library. Okay, so let's see. If I have the time, okay, I use this time library, and then I would like to time IT. It means I want to calculate the operational time. I want to group by based on the origin and carrier. And then I want to see how many data are available. So if I run this, okay, so the origin and carrier is in the, it is in the categorical data. Okay. Now, how if I move to the other? So if I move to the other data, we have, oh, sorry. This is, this is the original data, which is not categorical data. It is object. Okay, sorry. So this is based on the object data, and for the data that you use LC, okay, so we use this LC, so we change it to the categorical. Okay, so this one has been changed to categorical category data. And if you check this one, if you run, it takes time like 23 milliseconds. Okay? But if you use the object, it takes 41 milliseconds. Okay? So the time is quite big, for maybe what 50% different. Okay, so that's about the replace value. So note that the data frame with category data type is much faster. And now I'm going to discuss about the label encoding. What is label encoding? So when we are doing the label encoding, means we are going to encode the categorical values with a technique label encoding, which allows you to convert each value in a column into a number. And usually the number are between 0 until n-1. Okay. So we can do with very simple code .cat.codes. Okay. So for example, I have the carrier. Okay. So the carrier I do not change to. Okay, I do not change this carrier. So I have the original, which is AS. Okay, I have the original, which is AS, ES, and etc. And then I want to use the categorical data and codes. Okay. So if you choose the head, then it will automatically change to 0 until 10. Okay, because we have 11 data. Okay, because we have 11 unique elements, so it will automatically change from 0 until 10. So it is automatically. Okay. Then what is the difference between the replace values versus the encode label encoding? When you replace values, you can do with every value that you want. Okay. If you do with the label encoding, it means you need to use the format given by the Python. So sometimes you might just want to encode a bunch of categories within a feature to some numerical value and encode all the categories to some other numerical values. So you could do this by using Numpy, where function like shown below, you will encode all the US carrier flight to 1 and other carriers to 0. So it will create a new column in the data frame with the encoding. So you later can drop the original column and you can use the drop function in pandas. For example, let me just copy. Okay, I will copy to the variable specific. And then I would like to check if it is a US code or not. Okay, so this is just very simple way. I will teach you how to use the string in the next material. Okay, but in this case, I would like to use where. I guess you know already about where. It is about the condition. Okay, so it is a new column, and then where the carrier. Okay, where the carrier, and if I change to string, and if it is containing US, okay, so U, or S. Okay. So either U or S, it maybe this, oh, sorry, this one is US, okay, US only. So if it is US, then it is 1. If it is not, then it is 0. Okay. So there are many other string format. I will explain it later. So here, yeah, if it is US, then it is 1. If it is not US, it is 0. So you can use the label encoding with the scikit-learn label encoder. So you can use the sklearn label encoder, and then yeah, you can make an object lb make, for example. Okay. And then when you do with this, you want to see the carrier code. Okay. And the carrier code means it will fit transform. So this is a little bit complex. Usually when you use the scikit-learn, you will use this fit transform. So the carrier code will give you the code like 1, 8, and so on. Yeah, from 0 until 10. Okay. And yeah, the result in appending a new column to df. So there is a carrier code like this one. And in label encoding, it is pretty much intuitive and straightforward, and may give you a good performance from your learning algorithm. But it has this advantage that the numerical value can be misinterpreted by the algorithm. For example, should the carrier US encoded to 8 is 8 times more weight than the carrier AS encoded to 1. Okay. So usually when you use this label encoding, yeah, it is not that recommended, because the value will be from 0, 1, 2, 3, 4, 5. So the higher number can be represented as a higher weight or kachumchi. Okay. So if the weight is high, is it more reliable or something? Okay, so that's why people will go to one hot encoding. Okay. What is one hot encoding? One hot encoding. So the one hot encoding is the strategy to convert each category value into a new column and assign 1 0 or true false to the column. And this has the benefit of not weighting the value improperly. So there are many libraries out there to support one encoding, but the simplest one is using pandas.getDummies. Okay, let's see. This function is named this way because it creates dummy or indicator variables. Okay, and there are mainly 3 arguments. The first one is the data frame that you want to encode. The second is the column argument that which lets you to specify the column you want to do the encoding on. And the third is the prefix arguments that you want to specify with the prefix of the new column will be created after encoding. Okay, so first, second, and third is different. Now, let's see one by one. Okay. If I want to have the one hot encoding, let me just copy, and I will do the get dummies. Okay. In the get dummies, I will just use the data from the one hot, and then I will like to use the column carrier, okay, and I will use the prefix carrier. So here, the carrier is AA, carrier is AS, the carrier is B6, the carrier is DL. And whenever I create a new column, we have the prefix carrier. So this is the prefix, okay? Because this is prefix. So the prefix is carrier. And then we know that if the carrier is AS, then the value will be 1. And the remaining will be 0, 0, 0. Okay, this is the same row actually, but because it does not fit with the window, so it shows in the below part. So the first data is actually AS. What about the second data? Actually, this is US. What about the third data? The third data is UA. What is the fourth data? Fourth data is US. And fifth data, it is AS. Okay. So every column will be filled with this number. So if it is true, then it is 1. If it is false, then it is 0. Okay. So you can have carrier like this one. Or if you just change to CRC, for example, then yeah, you will have CRC. Okay? It depends on your prefix name. As you can see, the column carrier AS get values 1 at the 0 and for observation at those points had the AS category label to the original data frame. Likewise for the column also. Okay. And the scikit-learn also support one hot encoding via label binarizer or one hot encoder in its processing module. So just for the practice, we will just use the label binarizer. Okay. So here, if you want to just get the one hot encoding for the column carrier, okay. So here we can make a new object LB, and then this LB will be based on the column carrier, and then you make the data frame. The data frame is from the LB results here, and then make the column as a class. So you can have the categorical values turn into the 0, 1 like this. Okay. So note that this LB results TF resulted in new data frame with only one hot encoding for the feature carriers. This need to be concatenated back with the original data frame, which is done on pandas with the .concat. And the access argument is set to 1 if you want to merge on the column. So you can get this one hot encoding, and then you want to combine with the result after you use the scikit-learn. Okay. So this is actually the column that you just made before, and you combine it with the original data here. So you use the concat in order to merge between these two data frames. Okay. So while one hot encoding solves the problem of unequal weights given the two categories within a feature, it is not very useful when there are many categories. Okay, when you have a lot of categories, then yeah, it will create the curse of dimensionality. So if there are many dimensions, of course, yeah, it is time consuming. Okay, I will continue this one with another video.